Did you know that birdsong is a disturbance? In this video, we will look at how sound waves travel and see them in action, how a Rubens tube shows sound waves, and how the human ear works. If you wish to review the structure of longitudinal sound waves, watch this video. Sound is a longitudinal wave, pulsing like a slinky. Sound waves are technically a disturbance because they travel by disturbing the next particles along. What do sound waves need to travel? Sound needs a medium to travel through because it needs particles to disturb, which is why the vacuum of space is silent. There are no particles for sound waves to disturb. Usually, this medium is air, though it could be any material, such as water or steel or the ground. The medium is any series of interconnected and interacting particles, so it can be solid, liquid, or gas. So we have a medium. Sound then needs an original source of the wave. The source is any vibrating object that can disturb the first particle of the medium. The disturbance could be vibrating vocal cords, the vibrating diaphragm of a speaker, or the vibrating metal of a machine. We have our source and our medium to travel through. The sound wave is transported from one location to another by particle-to-particle interaction. As one particle is displaced, it exerts a push or a pull on its nearest neighbours, causing them to be displaced from their position. The Rubens tube is a spectacular physics experiment involving fire to demonstrate that sound is a longitudinal wave. The Rubens tube is a hollow tube that is filled with a flammable gas, usually propane. Holes are drilled at regular intervals along the top of the tube. One end of the tube has a rubber membrane stretched across it and a loudspeaker positioned next to it. The gas leaks through the holes at the top of the tube. The gas is lit, creating lots of small flames along the top of the tube. When the speaker is switched on, sound waves travel down the tube. The gas inside the tube follows the sound pressure wave and leaks out of the holes in a wave pattern. Therefore, the flames also appear wave-like, depending on which holes are leaking the most gas. How awesome is that? So, we've just shown how we can see sound. Wow! But how do we hear sound? We know that sound waves are actually vibrations passing through a medium. Our ear works by funneling these vibrations along through different parts of the ear, from canals to membranes to small bones, until the vibrations reach the fluid of the cochlea in the inner ear. The cochlea transforms the vibrating sound waves into electrical impulses, which are sent on to the brain. To learn more about how the ear works, watch this video. So while most people wouldn't agree, now you know birdsong is a disturbance of particles. And we can use fire to see sound waves.